Hi students, welcome to our channel. I am Dr. K. Varada Rajkumar, Associate Professor, Department of CSC, AIML, MLR Institute of Technology, Hyderabad. In our previous class, we learned about quicksort. In this class, we are going to learn about heap sort. So, overview of the presentation. In this presentation, we are going to see what is heap sort and heap sort algorithm, and finally we discuss about time complexity of heap sort. Outcome of this lecture, at the end of this lecture you all are understand how to apply heap sort algorithm to sort elements in an array. So what is heap sort? So heap sort is a comparison based sorting technique, so based on binary heap data structure. Heap sort processes the elements by creating the min heap or max heap using the elements of the given array. So what is heap? A heap is a complete binary tree, and the binary tree is a tree in which the node can have the at most 2 children. So what is a heap? Heap is a binary tree. So what is binary tree? So binary tree is a tree data structure. So tree data structure. So binary tree is also a tree in which the node can have at most 2 children. What it is? For example, this is the tree having 3 children. This is not a binary tree. Okay. So what is binary tree? So binary tree means in which the node can have the at most 2 children. Okay. But what is a heap? Heap is a complete binary tree. So what is complete binary tree? So complete binary tree is a binary tree in which all the levels except the last level, that is leaf node, should be completely filled and all the nodes should be left justified. What it is? So for example, so this is the tree, but it is not a binary tree. So what is binary tree? At most 2 children. So now consider this tree. So this is a binary tree but not a complete binary tree. What is a complete binary tree? In complete binary tree, in which all the levels except the last level leaf node should be completely filled and all the nodes should be left justified. Here it is, this node have one children and in the right side child have another children. What is a complete binary tree? All the children are filled from left to right. So if it is like this, then we call this as a complete binary tree. Okay, I hope you all are understand. So it is complete binary tree. In next unit we are going to discuss in detail about complete binary tree. Okay, so now coming to heap sort. So what is a heap sort? Heap sort is a comparison based sorting technique. So based on binary heap data structure. So what is a heap? Heap is a complete binary tree. Now here we have two types of heaps. One is min heap, another one is max heap. So what is min heap? In min heap, the key present at the root node must be less than or equal among the keys present at all of its children. That means always root is the smaller or equals to the children, and the same property must be recursively true for all subtrees in that binary tree. So for example, so 10 is the root now. Now here if I store 20, 30, now it is min heap. Why? The root is 10 is less than the children's 20 and 30. Now the same property we are going to follow recursively for all its subtrees. So here also 25, 28. Now so 20 is smaller than 25, 28. So 35, 40. So now 30 is smaller than 35, 40. Now, so these three we called as min heap. What is the min heap property? Always the root is less than or equals to children, and the same property we are going to follow recursively for all the subtrees. Here the subtrees are 20, 25, 28. So 30, 35, 40. Okay. In all these cases, the root is smaller than the children. So it is min heap. So it is max heap. So max heap is reverse to min heap. Always the root is greater than or equals to the children. So for example, so root is 100. Now, so 50, 80. For 50, 20, 30, 60, 70. Now what is the root? 100 is the root. Now it is the greatest element when comparing to children. And coming to subtree, here the 50 is the root. The children are 20, 30. Here 80 is the root, 60 and 70 is the children. So this heap we called as max heap. Okay. So what is heap sort? Heap sort is a comparison based sorting technique. So based on binary heap data structure. So what is heap? Heap is a complete binary tree. Here, so what is max heap? So max heap means the maximum element is act as a root. What is min heap? The minimum element is acts as a root. Remember these points to learn heap sort algorithm. Now coming to algorithm for heap sort, first build a heap from the given input array. That means arrange all the elements in complete binary tree. So repeat the following steps until heap contains only one element. Okay. Step 1, build max heap. Step 2, delete root node. Okay. So what is build max means? Build max means make the largest number as a root of the tree. And after building the max heap, you are going to delete root node. Okay. So let us discuss with one example. So this is the input. 28, 32, 10, 19, 8, 22. So let us assume this is the array A. These are the indexes 0, 1, 2, 3, 4, 5. What is the first step? Build a heap. That means build a complete binary tree. What is a complete binary tree here? So 28, next one 32, write 10, 19, 8 and 22. So this is the first step. So build heap from given array. So this is the given array. So this is the heap. What is a heap? So arranging the elements in complete binary tree. Complete binary tree means, so first number we consider as a root, second number left, third number right of the root. So we fill from left to right. Okay. So next step, build max heap. What is the next step? Build max heap. Now check 19 with 32. So 13 is the greatest. So we don't swap anything. Compare 8 with 32. Yes, 32 is greatest. So this is the subtree is a max heap. Now move to right side. 10, 20. What is the max heap property? Always the root is greater than children. So if we swap here, we get 22, 10, 10. So here it is 22, here 10. Okay. Now this is the max heap 28, 32, 19, 8, 22, 10. Okay. Now compare 32, 28. So 32, 28. So 32, 28, 22, 19, 8, 10. Yes. Next step is over. So build max heap. Here the largest number is 32. Now I make 32 as a root now. So what is the next step? Delete root. So delete root means this 32 is replaced with last element in the array. What is the last element? 10. So this is replaced with 10. Here it is 32. Okay. Now what is the array? Array is 10, 28, 22, 19, 8 and 32. Now in first iteration, the largest element is stored at the end of the array. Now so remove this and apply same algorithm. Okay, what is the algorithm? So we can repeat until the size of the tree is 1. Okay, now consider this as a input. Now compare 19, 28. Yes, it is max heap. 8 with 28. Yes. So 28, 10. Now it violates max heap property. So make 28 as a root, 10, 22, 19, 8. That's it. Now it is max heap. Now replace 28 with 8. So it is 8, 10, 22, 19, 28. Okay. Now so this is the resultant array. 8, 10, 22, 19, 28 and 32. It is the second iteration. So last two numbers are largest numbers in the array. Now remove this. Now this is the heap we have. Again construct max heap 19, 10. So it become as 8, 19, 10, 22. Compare 19, 8. 19 is greater. So 19, 8, 22, 10. Now compare 22 with 19. 22 is greater. So 22, 8, 19, 10. Now delete root. So 22 is replaced with last element. What is the last element? 10. So 10 is root, 8, 19, 22. Now the array is changed as 10, 8, 19, 22, 28, 32. Okay. Now so delete root node. The remaining elements are 10, 8, 19. Again build max heap 8, 10. Okay. So 19, 10. So make 19 as root, 8 and 10. And so replace 19 with the last element. What is the last element? 10. So 10, 8, 19. So what is the resultant array? The resultant array is 10, 8, 19, 22, 28, 32. So this is the fourth iteration. So last four elements are in sorted order: 19, 22, 28, 32. So now remaining elements, delete root 19. So remaining elements are 10, 8. Yes, it is max heap. So replace 10 with 8. So it become as 8, 10. So the array is become as 8 and 10. Okay. Now if you delete 10, what is the size of the tree? 1. Now that is the termination condition for binary heap. Okay. Now so this is the resultant array: 8, 10, 19, 22, 28, 32. What is the input? 28, 32, 10, 19, 8, 22. I hope you all are understand heap sort algorithm. So coming to time complexity, in the worst case, average case and best case scenarios, heap sort has a time complexity of big O of n log n. So where n is the number of elements in the array. So coming to summary of the lecture, in this lecture we will learn about heap sort. So heap sort is a comparison based sorting technique, so based on the binary heap data structure. Okay. So coming to algorithm, heap sort algorithm, first build heap, that means so arrange all the elements in complete binary tree structure, then build max heap and make the largest number as a root of the tree, next delete the root node. Okay. I hope you all are understand heap sort algorithm. In next class we are going to see the comparison of different sorting algorithms. If you have any doubts, so ask your questions in the comment section. I will answer all your questions. Thank you.